Hello, my name is Brian Dick. I'm a software engineer, and this is my second YouTube tutorial on a user-submitted challenge problem. Today's problem is zero-sum subarrays from geeksforgeeks.org. The problem is quite simple. You are given an array R of size n. Find the total count of subarrays having their sum equal to 0. In the example that they gave us, n is equal to 6, R is equal to 005500, and it returns the number 6. Explanation: there are 6 subarrays. They are 0, which is just the first 0, 0, which is just the second 0, 0, which is just the third 0, 0, which is the fourth 0, 0, 0, which is right here, and 0, 0, which is right there. So altogether, that is 6 subarrays. Now, the naive and simple solution to solving this would be to iterate through the array with a outer and inner loop, where the outer loop starts at 0 and goes over the entirety of the array, and the inner loop goes through the subarrays starting at the index of the outer loop. What this would allow is for you to go through every possible subarray within that array, and it will solve it in n squared time complexity, because you are basically going through all the combinations. So it's an n by n operation with that outer and outer loop, inner and outer loop. Now, that would be fine in getting the correct answer. However, the issue is what makes this problem so hard, and the reason why the accuracy on it is 50.41%, is due to these two restrictions. You have to have a space and time complexity of order n. So that is actually a pretty hard stipulation. Now, interestingly enough, I actually had this exact problem on a interview test. So this was one of my interview problems. They wanted to see how I thought this through. Now, one thing that I will say is anytime you see time complexity and space complexity of O of n on something that is normally done in n squared, that should be like a fire truck alarm going off in your head saying, hey, this is most likely going to be a hash table problem. And indeed, that's how we're going to solve it. So before I go into typing up the solution, I'm going to try to explain how we can use a hash table to give the proper answer here. So I'm going to go to Notepad here. I already typed everything up to kind of give you an idea. So basically what's going to happen is we're going to make a hash map displaying, let me go down just a little bit there, yeah. So the idea here is we are going to make a hash map where the current sum is the key, and the value there is a vector of the integers that are within this structure. So let me actually add that here. So we'll just have a hypothetical hash map of int sum and a vector of type int indices. That way it just is kind of clear what's happening here. So we go through each of these steps. When I is equal to 0, we would be adding this to our sum. So our sum is equal to 0. And whenever the sum is equal to 0, we know we have 1. So you go ahead and immediately increment 1. When I is equal to 1, so we are now here, and we've added 0 plus 0, then we have the sum is still equal to 0. We now can immediately, for the sum being equal to 0, we have 1. But this means that there was another subarray, because just before, we also had 0. So that means there was another, we have another subarray that is also equal to 0. The reason we know this is because in the hash map, when we go to 0 to the sum, we have a entry already there for 0. Since there is an entry there already, for every entry at this sum, we would have an additional subarray. So that would add another one in this case, because we currently had this sum, and then now we have this sum we get just from the results, or just from incrementing the results. But then once we go through that method, we are able to see that we had this subarray here, is essentially how that works. So then we move on to I is equal to 2. I is equal to 2, we add in this 5. We do not have a zero sum, and we have not seen 5 before. So our result stays at just the 3. We just have these 3 subarrays. The 0, and the 0, 0. We then go to index number 3. Index number 3 adds another 5. The sum is not equal to 0, so we do not add to the result. We have not had a 10 before, so we do not add to the result. And we move on. So now we add in the second, or the next set of 0. So at index 4, we have a sum of 10. Our sum is not equal to 0, so we do not immediately increment. However, we now have 2 10s here. That means between this 10 and this 10, there exists a subarray that had to be 0, because we've ended up in the exact same spot as we were once before. This means that for however many times 10 has come up prior to this, we had to have that many subarrays that we could have had before. In this case, we have the new subarray added of 0. So our result gets incremented by 1, making it 4. Okay, now we go to index 5, where we're adding 0 once again. Now we have a sum of 10. That means between this 10 and this 10, we have a subarray of 0. And between this 10 and this 10, we have a subarray of 0. Meaning that would add 2 to our total number of subarrays. So that would be accounting for this subarray and this subarray. Meaning our results get incremented by 2, making the result equal to 6. So that is how it works from a logic perspective. Now we'll go ahead and I'll show you how this works in implementation. Okay, so let's go ahead and code up this solution. So the first thing we're going to need is that hash map, or that hash table. The way that you can do this in C++, as I'm coding in, is called an unordered map. That is their term for a hash map. And we're going to do that language that we talked about before, vector of ints, and we're just going to call that our map, because that's what it is. This is our hash map. We are then going to keep track of our current results, the number of subarrays that we have, and we're going to set that equal to 0 because we currently have none, and our current sum because we haven't seen any values yet, so we are currently at 0 as well. We are then going to put in a for loop for int I is equal to 0. We're going to iterate over the total number of values, so n, and going to go up by 1s. And at the end, we're going to return result once we've gotten everything. So we only have a single for loop because we must do this in n space complexity, or n times complexity. So what we're going to do here is we are going to first increment sum by the value of r at sub I. So we're going to add in that first value, and we're going to check after adding if sum is still equal to 0. If that is true, we immediately increment the result, because we know for sure if our sum is 0, we have at least that is one array, one subarray that equals 0 as a sum. Okay. Next, we're going to do our second check. So we're going to see if in our map up here, if this already contains the current sum, then we have more subarrays that would also equal 0. So we're going to check to see map dot find sum. If this is not equal to map dot end, and this is whatever language you're using, you'll have some version of these. I'm not sure what the exact language is for Python or for Java, but whatever language you're using, you'll have some variant of these. The exact way of doing things might be a little bit different. In C++, the find method will return an iterator that points to the value at whatever location or whatever value you've put into the argument of find. If that value goes all the way to the end of the array, you get this special character called a end character. So if we're not equal to that map.end character, it will be, it means it found it, in other words. Okay, so if we have found it, then what we're going to do is we are going to increment result. So we're going to say results plus equals map at sum. So we're getting that vector, because remember this is a vector of nths, and we are going to increment by the size, of that result. Dot size, like so. Because however many times this has appeared before, that means there's that number of subarrays that had to exist between those. So there would be one subarray that goes from the first 10 to the second 10. If there was one subarray that goes from the second 10 to the third 10, in other words. And I'm saying other words a lot, sorry. All right, so that will cover all of our subarrays between those same values. And then we need to make sure that we're updating our map every single time. So we're going to say map at sum dot pushback. So we're going to push back on this vector of ints the current index. That way we continue to add to those vectors and we can properly get increment result here. And that should be all. That will then go through the array exactly one time. It'll have the total number of subarrays that are equal to 0, have added that number of times to results, and then return it there. Okay, so let's go ahead and escape out of this. Make this just a little bit smaller so I can see the submit button. We'll first go ahead and compile and make sure we do not type up anything wrong, because typos will ruin everything. We passed the original, and now let's go ahead and submit. It's going, and correct answer. Our execution time is 2.32 seconds. So I think that's pretty good. Anyway, I hope this helped you solve the zero-sum subarrays problem. Again, I think this is a very valuable problem to get under your belt and understand, because this will help you with all hash table type problems and help you think about how you can solve problems a little bit more creatively than just the brute force method. And this is something that I legit had this on at least one interview that I've had for either internships or full-time positions even. So yeah, if this helps you out, please give it a thumbs up. If you want me to solve a particular problem for you and walk through the steps of how it's solved and kind of give you my thought processes and going through it, let me know. And oh my gosh, my dog's barking. But anyway, thanks for watching. Please subscribe if you want more content, and I'll see you next time. Bye-bye.